So thank you very much for coming. I know everybody in this room is super busy. And so I'm just grateful that you're here. I have some things to share with you that I think you'll find very interesting and disturbing, actually. Today I'm bringing you bad news. Actually, I have good news and bad news. I start with the bad news. Basically the bad news, Christians are familiar with the bad news, and that is we are dying people in a dying world, and that apart from the Lord, we have no hope. The good news is Jesus has promised us heaven for anyone who would receive it, to be with him forever. That's the good and the bad news. But you can't appreciate the good news until you hear the bad news. And that's this message is bad news. Just like to say that I know that Darwin was the greatest atheist maker who ever lived. I know that for absolute certain. And I know that the evolutionary story destroys people's faith systematically. And for myself, when I was in high school, I loved science. I still love science. But my science teachers kept telling me that science disproves the Bible. So before I graduated from high school, I was a firmly atheistic, committed atheist. And atheism was my religion from that time until I was almost 40 years old. And so for the first half of my career, I had an evolutionary and atheistic point of view. And so for me, I can testify that breaking free of that was, number one, very difficult. After it's a stronghold in the mind, and so it takes there's a lot of baggage you have to deal with from a lifetime of thinking like an evolutionist. But when we step across the line and actually choose to believe God and his word as our ultimate authority, not man's authority, but God's authority, it's transformational. And so I went from a very dark place when I was in college to a life filled with joy and gratitude. And so I know that transition is something I would wish for all people to experience. And so that's my own personal testimony. Down, not up. When I was an evolutionist, I believed in 4 natural miracles. I believed that the universe made itself. It arose spontaneously without any design or purpose. And then life made itself. It arose spontaneously from chemicals. And then once you have that first bacteria, it's just, from there on, it's obvious that natural selection and mutation is going to make it evolve to higher and higher life forms, including forms of life that have brains and that have great beauty and amazing abilities. That's what I call the ascent of life. And so that's a miracle that a bacteria can turn into, let's say, a primate. And then lastly, the belief that man arose spontaneously. The human soul came. If you ask an atheist, do you have a soul? It's kind of difficult for them because they're not eager to say, I have no soul. And yet they can't give it a rational explanation. There's no mutation that gives rise to a soul. There's no typographical error that will do that. And so these 4 naturalistic miracles are foundational for what's normally taught in the universities. And so those of you who have considered these things carefully know that the idea of nothing giving rise to everything in a moment is absurd. We can refute that very strongly. The spontaneous origin of life, we could speak for hours about why that isn't feasible. Basically, life comes from life. Pasteur describes that. It's a natural law. It's called the law of biogenesis. And it's like absolutely certain life does not arise spontaneously from chemicals. But what you might be surprised is that the Darwinian process of mutation and selection cannot cause an ascent. It doesn't go from lower life forms to higher life forms. In fact, mutations are so destructive that the best natural selection can do is slow down the mutational process. And so actually this is false, and then common sense tells us that there's no series of mutations that will create consciousness or artistic talent or the ability to fly to the moon and back or a soul. So basically these are the four pillars of atheism, and basically they are all indefensible now. So it's amazing that God has shown us all that. So this is the topic for today. We're going to show that ascent doesn't work. So the book is Genetic Entropy, and the newest edition is a compilation, 15 years of research. And so this is something I've studied as much as probably anybody on the planet. And my findings are consistent with the highest level population geneticists. The problems that I'm going to describe, they also acknowledge. They acknowledge that the human genome is presently degenerating. So this isn't something I dreamed up. And I'm going to focus on genetic entropy, but I just want to let you know that by God's grace, there's all kinds of new developments that can encourage believers and that give food for thought for unbelievers. There's two secular papers that were just published in the last year or two. And there's a paper showing that all higher animals show the same type of bottleneck that is observed with the human race, which would be consistent with a biblical flood. That is, all of the mammals seem to have started from a tiny base, even two organisms. And so that's just an astounding thing. And there's another paper where they say they've looked at all RNA viruses, and they use a similar type of analysis. They conclude that all RNA viruses are young. You might think that viruses would go back millions or billions of years, but all the RNA viruses that they can study seem to be young. And so that's really interesting. Oops. There's other things here. Well, we just published contested bones, and we're going to talk about this a little later this morning, but it's a really exciting development because it brings all kinds of new insights into what's going on. And so the other exciting thing is Rob Carter and I are starting to write the book that we've been researching for many, many years, and it's going to be the genetic evidence for literal Adam and Eve. So that'll be exciting. And then we just published a flurry of papers in the last year, and these are all really exciting, but I don't have time to talk to them, describe them, so talk to me later if you're interested in those things. So our research on genetic entropy has not just been extensive, it's been published in secular journals. And so we especially use something called numerical simulation to understand how mutation selection plays out in simulated populations. And these are papers that we've published, and they're almost entirely in secular journals, in peer-reviewed journals. And then we have this is the papers that involve Mendel's accountant, which is our program, our numerical simulation program. And these are 5 other papers that refute neo-Darwinian theory. Neo-Darwinian theory, of course, is Darwin's theory of natural selection. He didn't know about mutations, genetics. It's basically an update of Darwin's theory, including the genetic element. That's neo-Darwinian theory. And so basically we have 20 papers, pretty much all secular, all peer-reviewed. And so this is not, I'm not just spouting this or making this up. We have earned a place at the table in terms of discussing this issue. So there's basically 2 worldviews. We're naturally going up or we're naturally going down. And so somebody's right and somebody's wrong here. Now, if there are people here who don't already have a biblical perspective, I'm really glad you're here. And what I'm going to say today is either going to convince you that I'm totally crazy, or that maybe there's going to be a paradigm change. If things are naturally if populations inherently go down systematically and don't get better, then the whole Darwinian concept collapses. So that's the question. Are populations, including the human population, going up or going down? It's really simple. And the question is, which is it? Okay, let's start with I'm going to divide this into very short little chapters so I can kind of make a series of points. My first point is, what is the scientific view of degeneration? So science, in general, says that all things degenerate, apart from intelligent intervention. Let's see. If you bought a new car, do you think it would maybe deteriorate over time, lose its value? If you bought a used car, would it get better or worse as you use it? So it's energy itself degrades, of course. You know that, because you put gasoline in your car, and it's high-density energy, and what comes out is exhaust, and it's low-density energy. The high-density energy can do work, and the low-energy, you have just as much energy when you're done, but it's gone from a useful state to a useless state. So basically, energy always degrades. It goes from high density to low density. Secondly, physical systems that are functional always systematically break down. That's another name for that is Murphy's Law. Basically, left to itself, things degenerate. Information is a non-material thing, but that also degenerates. And you know your laptop is going to be garbage in a few years, or it already is. And so if you play the whisper game, we know that as the chain of command goes, the person at the end of the line gets a corrupted message. So information systems degenerate. It turns out all living organisms, in fact, every single person in this room, is degenerating. You are more mutant today than you were yesterday. We're going to talk about that. And lastly, whole populations are degenerating. So basically, isn't that cheerful? That's the bad news. Okay, that's the bad news, is that apart from human intervention, and actually human intervention can slow these things down, but it can't stop any of these things. So scientifically, everybody agrees the sun is going to burn out, the universe is going to run down, heat death, and basically everything's going down. So how does evolution work if everything's going down? Isn't that an interesting question? I'm going to stand back here. I think it works a little better. So entropy means that everything is degenerating apart from intelligent intervention. And so entropy, people argue exactly how to define entropy, but there's some technical definitions where it's really just a measure of disorder. How do you measure disorder? But the common usage, if you just go to the dictionary and read it, it basically talks about this universal trend for everything to degrade or degenerate over time. So technically, entropy means a measure of disorder, but in the normal use of the term, it has to do with this process that disorder always gets worse. Okay, it's good to clarify that because some people want to argue that term. So that's the scientific view. Now let's look at the biblical view. If the Bible is right, then everything is wearing out and dying because of the fall. So is there evidence for the fall? Let's see. Watching the news last night. Any evidence have you experienced any evidence of the fall? Like sickness, death, suffering? Yeah, it's like ubiquitous, right? In fact, this is the biggest question in Christian apologetics. If God, why evil? If God, why death and suffering? And so, who can answer that? Nobody except Bible-believing Christians. It's amazing. So, Scripture says, for example, in Hebrews, you, Lord, in the beginning laid the foundation of the earth, and the heavens are the work of your hands. They will perish, meaning the heaven and earth, but you remain, and they will all grow old like a garment, That's entropy. Like a cloak, you will fold them up and they will be changed. That's the hope. The hope and the bad news and the good news are in that scripture right there. We are fading from 1 Peter. All flesh is as grass, and all the glory of man as the flower of the grass. And the grass withers, and its flower falls away, but the word of the Lord endures forever. So this idea of that we perish and that the physical universe itself is perishing is the bad news. So there's some data hidden in the Bible, some scientific data hidden in the Bible. It's really fascinating to look at. The Bible gives us the age of death of the first 20-some patriarchs, from Adam up to Moses. And so I remember as a young Christian looking at that data, those verses, and thinking, these numbers are crazy. Somebody made up the most ridiculous numbers. Why on earth is this in the Bible? But it's not crazy. It's like amazing. If you plot that data, the age of death of those early generations, we're going to start with Noah. Here's Noah, 950 years old before he died. That's pretty good, wouldn't you say? His son, Shem, poor guy, died at 600. And then as you plot the data, it fits a perfect biological decay curve. And so this is David, the last biblical data point. He dies of old age at 70. And this is the average life expectancy from birth of a Roman citizen at the time of Jesus. So how did that data get in there? It's data that is from Genesis and from Exodus and from other parts of the Bible. Were all the authors of the Old Testament conspiring to make it look like there was a biological decay curve of lifespan? I think this is incredible evidence for degeneration. Okay, part 3 is the personal view of degeneration. This is the one we can take very personally and is irrefutable. No one can argue against it. Mutations are killing us. Okay, so a mutation is a typographical error in our DNA code. It's basically just molecular mistakes. It's actually entropy at the level of molecules. And it's very disturbing to know that every time your cell divides, there are 3 copying errors, 3 new mutations every time you have a cell division. And of course, you have trillions of cells in your body, and they're all dividing, so there's a lot of mutation going on in us. And so this is the essence of genetic entropy that we experience personally. So here's Michael Lynch is a very prominent population geneticist, and in his inaugural, he was initiated into the National Academy of Science. So in the Proceedings of the National Academy of Science, this was his first paper. And he was talking about this problem of mutation accumulation in our bodies. And he said the average skin cell in a 15-year-old has 6,000 mutations, new mutations, since conception. From your conception to if you're a 15-year-old, you have 6,000 new mutations on average in every cell of your body. Did I mention that this is bad news? Yeah, it is very bad news. But we already know it. It's not new news, but it's bad news. Skin cells of a 60-year-old man, someone like me, up to 40,000 new mutations per cell. And so mutation is the primary cause of aging and death. So this is sobering, but it's not new. We all know that we age and die. But it's interesting to know that we know why. And so he says there's little potential for substantially increasing the upper limit of human lifespan because this is built into every cell division. It's not, there's no escaping it. So if you're hoping for a miracle cure for death, don't hold your breath. Okay, so genetic entropy in the individual is undisputed. Every scientist would agree with it. We experience it. Basically, we start out with perfectly programmed bodies. By the way, our DNA is the programming of life, very sophisticated programming, and that's what holds us together, but mutations tend to undo that. So next we're going to look at the view of not the individual but the population. So it turns out that unfortunately we pass on some of our mutations to our children. So basically we each inherit a whole host of mutations that have been accumulating in our ancestors and in our parents. We get that from our parents, and then from the very first cell division of our new being, when we're just a zygote, that very first cell division, 3 mutations for the 2 daughter cells. And then the four daughter cells that come from those, 3 more mutations for each one of those. And it goes on and on. So that transmission from generation to generation is very concerning. It means that life itself is wearing out like a garment. It means that entropy doesn't just cause death of people. It should cause every species to eventually go extinct. So, how many mutations get transmitted? Well, everything, if you're a parent here, you have all the mutations of your parents plus the 100 new mutations that you've added to that. Now, you don't have the 40,000 that are in your body cells, but in your reproductive cells, there's still 100 new mutations that accumulate. Those cells are actually protected from mutation, but not completely. So about 100 new mutations get transmitted to our children. So our children are more mutant than we are, and our grandchildren are more mutant than they are. So you can see basically everybody in this room is 100 mutations more mutant than your parents. So can you see that this is, even with selection, that you can't get rid of mutations as fast as they pour in? It's a huge problem. There are huge numbers of bad mutations in our genome, but most of them are tiny, so they don't show a phenotype. But we see that 2 to 3% of babies show visible birth defects. This is the first manifestation of the problem, but most mutations don't show up as a visible defect. They just accumulate like rust on our, as time passes. This is tragic. And so thousands of genetic diseases are known. The best example of a beneficial mutation, so these are all deleterious mutations. The thousands is just the ones that really have major impacts so that people can see that it's being passed on from generation to generation. Most of the mutations accumulate without us seeing. They're not identifiable one by one. So do other geneticists agree with this? They do. So Dr. Kondrashov is a population geneticist. He was at Cornell, and then he was at NIH, and now he's at Michigan. He told me in a private conversation, there's no human geneticist who doubts that man is degenerating. Dr. Crow, the most distinguished geneticist, I think, in the last century, last half of the last century, he said, we're inferior to cavemen. Fitness is declining at 1 to 2%. This was published in PNAS. This was a high-profile paper by a high-profile scientist. And Dr. Lynch says in his more recent paper, we are degenerating at 1 to 5% per generation. So this is bad news, but it's not. But it's well established. So 1%, 2%, 5%. Let's just consider 1% and just draw a plot. If you start out with a fitness of 1, everybody is fit, and you start introducing mutations, and the fitness is declining 1% per generation. After just 300 generations, basically you're approaching extinction. You see a radical biological decay curve. Okay, so here's Michael Lynch in his PNAS paper. He says in a few centuries, we will see significant incapacitation at the morphological, physiological, neurobiological levels. So Lynch says that we're going to see that, and he suggests, well, we just have to go to the third world where there's a higher rate of death, and that'll be filtering out the bad mutations. Doesn't work like that. Basically, premature death is mostly due to circumstance, not genetics. So actually, even a draconian selective system that would eliminate the unfit. This doesn't stop the problem. So there are aberrant populations from the past, and these have been used as arguments for evolution. There are some pretty weird-looking human bones in the fossil record, and they say, this is a pre-human. But they're not. They're humans that have experienced genetic entropy. So we can show evidence for this in Neanderthal, in Homo erectus, in Hobbit, and in Naledi. So this is huge. I'm going to go through really fast because we're going to talk about that a little later this morning. But here's a brand new paper showing that these early hominins, these pre-humans, were actually fully human, and they have all kinds of genetic problems. Why? Because they lived in tiny little tribes, isolated from the rest of the world, and they inbred, and there was rapid inbreeding and genetic damage. So those are some of the scary skulls that we see. These are not pre-humans. These are people with serious genetic pathology. Same thing here. So the bottom line is neo-Darwinian theory says that things should go up and up and up. But what we see is things get worse and worse. So Darwinian theory, the mechanism of Darwin is mutation, selection, explains everything, including us. And the reality is that mutations only take us down in a very systematic way, and selection can only slow that process. So people say, beneficial happen. They do, but they happen too rare, too little, too late. Selection happens, it does. There's some adaptation going on, but it doesn't actually reverse the downward trend. And so change happens, but change isn't evolution. The change we're talking about is down, not up. Okay, we're going to just skip over some things. Numerical simulations is what we've used as our tool. And we developed a program with a team of scientists called Mendel's Accountant. It's a program that operates like a genetic accounting program. It tracks every component of the system through time. I want to keep moving, so I'm going to go a little fast forward, but I come back to these papers. Our work has been published. No one's challenged the validity of our program or our results. When we do a realistic simulation using realistic mutations rate, the mutation rate, as I mentioned, was 100 new mutations per person per generation, and we model that within a 200 generation time period. Why 200? Because that's about how many generations since Adam, if we take the Bible literally. What we see is this fitness decline. Does that look familiar? So that fitness decline is very dramatic, and it shows it's very close to the biblical decline that we see here. This is truncated. We don't see Noah on this picture, but it shows the same type of curve after Noah. This looks like the 1% decline that Crow says has happened. The waiting time problem. We use the numerical simulation technology to answer a lot of questions. Here's a really interesting question we answered. How long do you have to wait for a set of mutations to arise, a string of mutations, in a pre-human population? It's assumed that the ape-man intermediate population was always about 10,000. People say that as if they actually counted them, but that's the claim. In that type of a population, how long do you have to wait to get, let's say, 2 specific beneficials? Usually a single letter change doesn't create new information. So let's just ask for 2 beneficial mutations, or 3 or 4. Because if you're talking about language, a letter doesn't communicate information, right? But a word does. So the minimum amount of information is a word in our language, and the minimum amount of information in a genome should be these short strings of letters. Okay, this paper was published 2 or 3 years ago in a secular journal, and it's been downloaded by 10,000 people. So these people are, for a technical paper, that's a lot of readership, and there's not been a single response that's negative. No one's challenged this research. Why should they? Well, because the results are amazing. Okay, so if we, If we're going to plot here string length, here's a string of 2, which is just 2 letters. We're asking for like a word like at. A string of 3 up to a string of 8. These are just tiny genetic words at best. And this is the waiting time. How long it takes for the right mutation to arise. You have to wait a long time for a specific nucleotide to change into a specific other nucleotide. And if you have 2, it takes much longer. And so, so we're just going to look at this, and I'm just going to go through it real fast. But just to get one mutation in this type of population takes 1.5 million years. That's a minuscule amount of information. But the ape to man story says in 6 million years, we radically redesigned the genome, creating human mental capabilities. So there's vast amount of information. Here we have a waiting time for a letter of 1. What if we ask for a letter of 2? So 84 million years to get the smallest genetic word. 3, okay, it goes up really fast. 4 is over 1 billion years, and so 6 is greater than the age of the Earth. And you just wait getting one word, one genetic word. And at 8, you have greatly exceeded the time, the reputed time since the Big Bang. There's not enough time in the universe to create an 8-letter word. It's crazy. I'd have to explain it to you. If you read the paper, it's clickable. I'll give you a website so you can click on any of these papers you want. But it's very incredibly strong paper. The waiting time, just by itself, just the waiting time problem, precludes human evolution. Absolutely. Absolutely. Part 7, looking at biological data. So those are numerical simulations. Now we did a numerical simulation to see if we can't do a biological experiment with people. Let's say we're going to measure the genetic entropy in man for 1,000 years. Well, I won't be around to see the results from that experiment. But if you have a model organism like a virus, there are lots of generations, and we can actually sequence those small genomes and actually see how they've been changing over time. So we can see a real biological system and see if it goes up or goes down. And so we did preliminary simulations to see if it would decline, and it indicated that something like the influenza virus should degenerate and go extinct. So then we published a paper a few years back, Rob Carter and I, and the paper is entitled "New Look at an Old Virus: Patterns of Mutation Accumulation in this Human H1N1 Influenza Virus since 1918." In 1918 was the great influenza pandemic that killed 50 to 100 million people. Many more people were killed by that influenza outbreak, global outbreak, than died in World War I. That pandemic was the H1N1 strain. So we're going to be studying only that strain. Okay, so it turns out that people were collecting samples of that virus going all the way back to the 1930s. And so we have a historical record, a fossil record, so to speak, of the virus. And bottom line is, mutation count went up linearly over time, and 10% of the whole influenza virus mutated since the 30s until the present, and the mutations accumulated just like clockwork, which is what our simulations prove. And there's a break here. It has to do with, I'm not even going to explain it because I don't have time, but the bottom line is the mutations accumulated, 10% of the genome mutated. Other people have done research on the virulence of this strain. In 1918, it was incredibly hot virus, and so it killed so many people. But very quickly, that strain petered out and virulence declined, approaching zero. It looks like a biological decay curve, and it is. And guess what? It went extinct in 2009. That strain went extinct. And so this really validates everything we've done, all of our numerical simulations, and its biological reality. And if anything can resist genetic entropy, it should be a virus. So this is really impactful. This reminds us of our simulations. It reminds us of Crow's prediction that we were degenerating 1% per generation, and it matches the biblical data. It's very, very strong. I'm going to skip right to the bottom now. The bottom line is genetic entropy is real. It's supported by the laws of nature. It's obvious at personal level, compelling logical at the population level. Honest numerical simulations nail it, and viral and bacterial studies confirm it, and the attempts to explain it away have failed. That's the bottom line. All right. Thank you so much for your patience. I think I'm out of time. Am I out of time, Russ?
We have time for questions for about 5 minutes.
Okay. I'm sorry I'm confused about the time, but it's 9 o'clock and my clock here is wrong. So it makes me a little bit... you'll tell me, you'll cut me off, okay, Russ? Thank you. Okay. Questions? Yes?
How does biologos, organizations that are Christian, trials, for example, how do they respond then? How do they respond to the argument that you're putting forth that there's not enough time? Obviously, they believe in theistic evolution. Is it that God hurried the process, or how do they respond?
So biologos is a huge topic. I'm not sure why I'm giving feedback, but biologos is a very powerful organization. So the fact that Francis Collins, head of NIH and former head of the Genome Project, his impact is very great. He's a Christian, and biologos, some I think are Christians, some aren't, frankly, but they're militantly pro-evolution. They not only militantly reject any type of creation of old Earth or young Earth, they militantly deny design, which is really remarkable. In other words, they don't believe God's in it. He made the Big Bang, and that's kind of the last time he was involved. So it's a remarkably unbiblical worldview, and yet they have influenced most seminaries to go with that, and they've influenced most Christian colleges to go there. And so if you send your kids to a Christian college, even if they say Christ affirmed and everything, and we believe in creation, a lot of those colleges actually now are teaching straight up Darwin. They're hostile to even intelligent design, and a lot of them are really doing false advertising because they say they're going to teach a biblical view, but they actually are hostile to a biblical view. So I have very strong feelings about biologos. I know I have brethren there, but I also think there are false teachers in that group. And so I'm very disturbed that they would even take, they are more eager to attack the ID proponents than Christians. They're really hard on discoveries.
Thank you. And one suggestion, if you move between the two speakers, you won't get as much feedback.
Okay. Between.
Here, we're right under one.
This way? Okay. Okay. Yes?
Just a quick question. You went quickly to the time it would take for any positive mutations. I thought I heard you say that there weren't, the likelihood of positive mutations was almost non-existent. But you're conceding there are some positive mutations, but the time is not adequate. Did I read you correctly on that?
So that's really a good question. Beneficial mutations are feasible. They're hard to find. The ones that are beneficial tend to be reductive. So one of the most famous beneficial mutations is sickle cell anemia, which of course is a disease. It's a genetic disease. It's very serious. But it happens to also, it's so destructive to the red blood cells that they're seriously misshapen. They're so misshapen that the malarial parasite doesn't want to infest them and multiply within them. So it's actually what we would call a reductive mutation. You have a broken gene, a broken protein, and a broken cell type. And so the pathogen can't invade that person, so they have resistance to malaria. but they have a very serious genetic disease. That's called reductive evolution. Most beneficial mutations overwhelmingly are reductive, either deletions, or broken genes, or some type of other. The few mutations that are truly beneficial and not reductive would be like adaptations, like fine-tuning to your environment. Those mutations can be beneficial. We can acknowledge those. But generally, beneficials are exceedingly rare and usually reductive. And lastly, we don't assume that those are all beneficials, but if you're going to create the new information that would change a chimpanzee into a human, which would be a lot, you have to presume that new strings are going to be beneficial and that they're going to somehow add to that total amount of information. But even waiting for a string of 2 isn't feasible in the ape to man scenario. Yes. The red shirt, please.
Very interesting presentations. Enjoyed them very much, and thank you for being here. If I'm not mistaken, you actually gave a talk to the NIH recently, and that would have been a very biologically informed audience. And so, if that's true, and if I'm not mistaken, you talk on genetic entropy. And so, if I'm just sort of curious what the reaction would have been in that environment.
So I had the privilege of speaking at NIH. And it was a great opportunity. I laid out all the evidence that specifically the human genome is degenerating, and therefore the human race is degenerating. And it was my one chance to really speak to my peers at a high level, and it was very persuasive. I would say the people who came there were no hostile people in the audience. And the audience was very interested, asked really intelligent questions. No one challenged what I was saying. Because like I said, population geneticists, I quote a lot of population geneticists in that talk. And so it's really clear that the problems that I outlined aren't new. Population geneticists have known from them from all the way back to the 50s. But they haven't necessarily gone public with them. Like you can find it in their papers, but they don't really want to tell the public that the human genome is degenerating, partly because it undermines evolutionary paradigm. Yeah. Did you have a question?
I actually just have a clarification. So the numbers that you gave about strings of 2, 3, 4, those are, and you told all of your assumptions of population 10,000. That's not just for that mutation to arise, but also to fix itself in the population.
That's exactly right. So basically, we're asking how long from when the mutation actually not only does the mutation have to arise, it has to in one person. Well, it's usually going to arise only in one person because it's really rare, way a long time, and then it has to survive. Usually, a new mutation like that is right on the edge of extinction, and so it can arise several times, many times, maybe 100 times before it catches hold. Then natural selection can amplify it, so everyone has it. That's part of why the waiting time is so long. But even just waiting for a string of, let's say, 3 to arise, apart from the rest of it, is still huge waiting time, way too long for the ape to man story. Yes?
Have you had anybody challenge you on your research and your conclusions? And if so, what has been the greatest challenge and how have you answered?
So, no qualified geneticist has challenged me. There were 2 kind of internet bloggers who have attacked my position, and one was a physicist and one was a mechanical engineer. But I haven't had any. I think people speak of me in private, probably in ways that are not encouraging, but I don't hear those conversations. Mostly I'm ignored, and it's kind of like a shunning thing. So if I email a fellow population geneticist question, they almost never would answer. So I don't experience attacks outside of kind of like atheist blog sites. I mostly experience, I'd say, shunning. Yeah. So there's no basis for a polite conversation.
What do you think of a meeting to be able to impact the
genetic structure, really influential genes to impact the genetic structure.
Right. So a meme is like it's kind of like a new idea. It's like almost goes viral. And the question is, could there be a selection for people who have that meme? Is that the idea? I think that there's very little of that. Basically, selection is subject to noise. So if you're trying to select for height, weight, IQ, and curly hair, you have to have, the more you select for other things, the more it interferes with selection for a single thing. And so natural selection ends up needing something really significant to grab hold of, and before you can get it amplified by selection. So I don't actually believe that memes are genetically transmitted, ever. But I do think ideas are infectious. So there are good ideas and bad ideas, and so there are lies and truth, and that's kind of the nature of spiritual warfare that we engage in. Yes?
So in regards to the genetic diversity and just following the line of thing, so how do you account for genetic diversity if you just take into account just following Adam's line?
So that's a great question. I'm going to address that tomorrow morning at a church, but I'll just give you a soundbite.
Repeat the question.
Okay, so it's often argued that a literal Adam and Eve is impossible because it takes too long to generate diversity through mutation. And so we see a great deal of diversity in the human race, and the question is, how did you get there in a short, if you have a young Earth perspective? And so it's a common complaint. It actually has an easy answer. So in Eden, there would have been 4 sets of chromosomes. And so God could have created all kinds of good diversity into the genome of those 4 different sets of chromosomes. So Adam and Eve could have been polymorphic, or let's say heterozygous, at millions and millions and millions of loci. You can invoke any amount of design diversity. And so design diversity explains that. And then there's a follow-up question as to the allele frequencies. We also have solved that problem. So we can actually get the allele frequencies that we see today from 2 people. It takes special circumstances like biblical circumstances, but it gives you exactly the same allele frequency that we see in the population today. So it's a lot of people's faith have been shaken by these arguments that are coming not from the atheists but from biologos, but we've been able to address them. So thanks for your patience.
We'll take one more question.
Okay.
One more burning question. And if not,
Where will you be speaking tomorrow?
it's on your program.
Okay.
Okay.
On the back, underneath the breakout sessions. Go ahead. You have a follow-up, real quick?
Not necessarily follow up or anything. Just curious thing. Is the genetic entropy rate, is that similar to the entropy rate of the universe or anything? Or is it greater? Or is it, because it's just similar to the point that's just the point that explained as just a natural process?
So I think it's the same phenomenon that is the second law of thermodynamics says that energy always diffuses, and at the material level it means that there's degeneration. Everything goes to its lowest energy state. So the same process, the speed of it is a function of variable parameters. And so how fast we mutate is partly determined by the mutation rate, which radiation can affect that, stress, lots of things. So if we can reduce the human mutation rate, that would have a huge impact in terms of reducing suffering and creating more longevity. So I'm a big advocate for reducing mutation rates, if possible.
That's good.